Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So we are going to see a video lecture series on network theorems and source transformation in the subject circuit analysis and devices. So in this video we will see about superposition theorem. So superposition theorem states that in any linear and bilateral network or circuit having multiple independent sources, the response of an element will be equal to the algebraic sum of the responses of that element by considering one source at a time. We can also say that the response at any point in a linear electrical network with multiple independent sources can be calculated by calculating the individual contributions of each source while assuming the other sources are turned off or replaced by their internal resistances. Superposition theorem, it is used in electrical circuit analysis, which indicates that in a linear network any one branch of voltage and current can be found by inspecting the effect of the independent source respectively. The superposition theorem only applies to linear circuits in which the relationship between voltage and current is constant and does not include nonlinear components such as diodes or transistors. It can significantly simplify the analysis of complex circuits, especially when there are many independent sources. However, this theorem can be time consuming for circuits with a large number of sources, as you need to perform separate calculations for each source. In such cases, other circuit analysis techniques like nodal analysis or mesh analysis might be more efficient than superposition theorem. So next we will see some guidelines for using the superposition theorem. So all the components must be linear with the circuit voltage and current whenever using the superposition theorem. Since power is not a linear quantity, it should not be used with power. Ideal voltage source should be removed. Ideal current source should be removed so that it can be replaced with an open circuit. Next, real voltage source should be removed to replace with the internal resistance. Consider one source at a time from the various multiple sources. Replace all the other impedances with their internal resistances. Calculate the current flowing through the source and the voltage drop across it. So you have to take the algebraic sum once all the current sources and voltage drops have been calculated. So next we will see how to apply superposition theorem. So the first step is to select any one of the multiple sources present in the network. Among the various sources, any one of the sources can be considered first. Except for the selected source, all the other sources must be replaced by their internal impedances. Using a network simplification approach, evaluate the current flowing through or the voltage drop across a particular element in the network. The same considering a single source is repeated for all the other sources in the circuit. Upon obtaining the respective response for individual sources, perform the summation of all the responses to get the overall voltage drop or current through the circuit element. So these are the steps that has to be followed in superposition theorem. So let us see an example. So in this given circuit, find the current flowing through the 20 ohm using the superposition theorem. So first we have to consider any one source. So here you are considering only the voltage source and we are removing the current source. So the current source will be open circuited and the circuit will be as shown here. So we have to find the voltage using the nodal analysis method. So in this the center point is V1. So we can write the nodal analysis equation as follows. So V1 minus 20 by 5 as shown here. So V1 will be the center point. So V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20 is equal to 0. So from the circuit we will be getting the nodal equation. So from this nodal equation we will be finding out what is V1. So V1 will be equal to 12 volts. So next, once we find the V1, we have to find the current flowing through the 20 ohm resistor. So current flowing through 20 ohm resistor can be calculated by I is equal to V by R, where here in this circuit R is a series with 20 ohms is in series with 10 ohms. So we will be writing it as I is equal to V by 10 plus 20. So current value will be 0.4 amps. So this is the current with the help of voltage source alone. Next one, we will be short circuiting the voltage source and we will be having only the current source. So here the 4 amps current source is there and the voltage source is short circuited. Now we have to find out the current through 20 ohm resistor with this current source. So in this first we can calculate the equivalent resistance in the left side of AB. So when we see here your 5 and 10 ohms are in parallel, which is in series with 10 ohms when we see from AB point. So 5 in parallel with 10, you can write it as 5 into 10 divided by 5 plus 10, and which is in series with 10 ohms. So now this is a simplified circuit. So you will be getting the equivalent resistance as 40 by 3 ohms. Now you can find out the current flowing through the 20 ohm resistor using the current division rule. So you know that the current division rule is a total current into opposite resistance divided by sum of the resistance. So you want to find out the current through 20 ohms. So the total current is 4 amps. So 4 into opposite resistance is 40 by 3 divided by 40 by 3 plus 20. So you will be getting answer as 1.6 amps. So the total current is the sum of both the currents, that is current through the voltage source and the current with the help of current source alone. So here I1 plus I2, which is 0.4 plus 1.6, which is equal to 2 amps. So the current flowing through the 20 ohm resistor is 2 amps. This is how we will be finding out the current using superposition theorem. So there are some limitations of superposition theorem. So this superposition theorem does not apply for nonlinear circuits. So here the requirement is linearity, which indicates that superposition theorem is only applicable to determine voltage and current, and we cannot find out the power. Power dissipation is a nonlinear function that does not algebraically add to an accurate total when only one source is considered at a time. So the application of superposition theorem requires 2 or more sources in the circuit. So we will take up some assessment questions. So what is superposition theorem? Yes, superposition theorem is a circuit analysis theorem that is used to solve the network where 2 or more sources are present and connected. Next one, is the superposition theorem valid for AC circuits? Yes, it is valid for AC circuits. Next question is, can the superposition theorem be applied to nonlinear circuits? No, superposition theorem is used only for linear circuits. It cannot be applied for nonlinear circuits. Next one, is it applicable to power? No, you cannot use it to calculate the power. You can use only for calculating the voltage and current. Next one is, where do we use the superposition theorem? So superposition theorem is very important in circuit analysis because it converts a complex circuit into a Norton's or Thevenin's equivalent circuit. Thank you for watching this video.